9.9 right triangle similarity is what we're doing today. Now the first three vocab words that we have right here, major review on your part. In fact, I'm hoping that a lot of you just use this on Smarter Balance and recalled this information. A right triangle, that's a triangle with a 90-degree angle. Legs, those are the two sides that form the 90-degree angle. And then the hypotenuse, that's the side opposite of the 90-degree angle. It's always the longest side. So if you have your triangle, you have your 90-degree angle. Your legs make up that 90-degree angle. So there's your A and your B. And then what letter do we usually give to the hypotenuse? The C. So get those definitions written. And the last three vocab, similarity, when two shapes have corresponding angles that are congruent and their corresponding sides are proportional. Alright, so ways to prove similarity of two triangles. You prove that the angles are congruent, and then, or you could prove it by showing me that the sides are proportional. So you find the ratio of each side, and if they all have the same ratio, they're all proportional, that proves they are congruent. And that they are similar. Now when we talk about similarity, it's a little recall from the beginning of the unit. When we talk about similarity, similarity only applied to which transformation? Was it rotation, translation, dilation? What was it? Which one of those refers to similarity? I think I heard it. Which one? Dilation, right. Because when you did a dilation, if you did it correctly, they were similar. They weren't congruent. All the angles were congruent, but the side lengths changed. But yet if we did, and I believe we did do that, that when we figured out the ratios of the sides, they were all equal. And then of course the grand one at the bottom there, the slope, rise over run, the vertical change over the horizontal change, positive, negative slope. Alright, example 1. Up here it tells us, given triangle ABC and triangle DEF, answer the following questions. Measure of angle B equals 56 degrees. So if you look down here, measure of angle B is 56 degrees. Measure of angle D is 34 degrees up here. So by looking at the degrees, we know that these two are not what? These two angles are not what? Congruent. Now let's go down here. It says list all the pairs of corresponding congruent angles and their angle measures. So looking up here, what angle is congruent to angle A? So here's angle A. Which one is congruent to angle A? I'm hearing D. How do we know that? We can look up here, ABC, DEF. A is to D. Alright, so we'll put the letter D there. How about B? B is congruent to what? B and E. So those are congruent. What is the measure of their angles then? Of B and E? They both are what? 56 degrees. What were the angles then of A and D? Yep, they told us that these two were 34 degrees. Now, if we look at angle C, right here, which one is congruent to C? The F. What is the measure of angles C and F? 90 degrees. How did we get that? Well, there's two different ways. You could have added these together and you got 90. 180 minus 90 is 90. Or on your calculators, 180 minus the 34, 180 minus the 56, you would have ended up with 90 degrees left over for here. All right, now I'm going to clear this off again. We're looking at our triangles. It says down here, part B, explain how you could prove that triangle ABC is similar to DEF. Well, we kind of proved it here, didn't we? If we prove this, if we said that's true, that these angles are congruent, that proves it there. But how about if we look at the sides here? If I look at AC and DF, how many units is AC? Right here. This one is 3 units. How about from BC? How many units here? 2? Am I counting that right? Do we know how many units here? No, we don't know that. But we do know that this is our right angle. We just figured it out. This is our 90-degree angle. So what could we call this? Instead of a question mark, what could we label that side? The C. And what is the C known as? Our hypotenuse. So here, what is the legs up here? How long is this leg? EF is how many units? 4 units? 6 units? And then this will be labeled our C. So we're going to have to do the Pythagorean theorem. And we need to find, well, first let's do the easy ones. Let's do our legs. Find the ratios of our legs. What's AC to DF? AC is what? 3. So we have 3 over, what's DF? 3 over 6. And what does that simplify to, Alex? That would simplify to what, class? 1/2. So that one's 1/2, but the other two have to be 1/2 also, or they're not similar. What's BC? BC, how many units? Right here. 2. We have 2 to what? EF is what? 4. So 2 to 4 simplifies to 1/2. So far, so good. Those two work. Now we have to find the Pythagorean theorem, find our hypotenuses here. So over here, if I have my two legs are 2 and 3, 2 squared plus 3 squared equals C squared. What's 2 squared? 4 plus, what's 3 squared? 9. That equals C squared yet? So 13 equals C squared. So is it 13? No, we need to find the square root of this. So on your calculators, 13, hit the radical sign. What is the square root of 13? 3.6. Excellent. So that's the length of AB. That's the ratio. So it's 3.6 to what? Now let's go up here and do this one. What do I have? 4 squared plus 6 squared equals C squared. What's 4 squared? 16. What's 6 squared? Nice. 36 equals C squared. 16 plus 36 is 52 equals C squared. And now I have to find what? The square root of that. So the square root of C squared is C. What's the square root of 52? 7.2. So we have 3.6, and now DE, now we know that that is 7.2. Does that simplify to 1/2? If If you're not sure, you can go on your calculator. 3.6 divided by 7.2. What does that equal? 0.5. What is 0.5 as a fraction? 1/2. 5/10 equals 1/2. So we just proved that these are similar because all their sides are proportional. So then they ask us right here, what is the ratio of the lengths of the corresponding sides? We just figured that out. What is the ratio then? What to what? We just did all three sides. What was the ratio we came up with? 1 to 2, 1/2. So our ratio is 1 to 2. Now, who wants to predict? Predict what will be true about the slopes. So you're looking at this slope right here and this slope right here. What do we know about these slopes on these right triangles that we just figured out? What could we say about them? They are what? They are, there's a couple different words we could use. They are, don't think too hard. One word starts with an E, one word starts with an S, and it's not similar. We're talking, they are the same. They are the same, or they are equal. They are the same, or they are equal. All right. Your homework for today, pages 5, 6, and 7. So the rest of that packet, that worksheet packet that you have, pages 5, 6, and 7, due tomorrow.